This is section 5.2, the integers and order of operations. Here we have some definitions of some subsets of numbers. Let's go through them one at a time, make sure that we understand them. We've defined natural numbers in a previous video, but let's define it again. It is the set of counting numbers. So of course the counting numbers that you learn whenever you're a little kid, 1, 2, 3, 4, 5, 6, all the way to infinity. These are the natural numbers. Expanding this set of numbers, we include 0. Whole numbers are the natural numbers and 0. So you can see the set of whole numbers here, again going all the way to infinity. Expanding our understanding of numbers even further, we include negative numbers. So this set is called the integers, and it is the set consisting of the natural numbers, 0, and the negative of the natural numbers. Now you probably remember this from past math classes, the number line. The number line always has 0 in the middle. To the right are positive numbers. To the left are negative numbers. The number line includes all numbers, but usually just shows integers. Note that 0 is neither positive or negative. Then we have the inequality symbols. Less than, greater than, less than or equal to, greater than or equal to. It's important to note that the equal to symbols have the greater than or less than symbol along with a line underneath them indicating also equal to. Graphing an inequality. So we have 4 examples here of inequalities, and we need to graph them. So let's go through this. We always graph an inequality on a number line. So let's start with number 1. Here's my number line. 0 in the middle. To the right, 1, 2, 3, 4, 5, 1, -1, -2, -3, -4, -5. So the inequality symbol in number 1 reads x is less than 3. If you don't recall how to read an inequality symbol, what I like to do is think of Pac-Man. If you remember the video game Pac-Man from the 80s, it's still around today. Pac-Man likes to eat the bigger piece. So in this case, x is less than 3. So in order to graph this, x cannot equal 3, so what we do is we go over 1, 2, 3, and we put an open circle indicating that x does not equal 3, and then x being less than 3, we draw a line to the left with an arrow on the end. So that would be the graph of x is less than 3. All right, let's move on to our second example. Draw another number line. And now our inequality says x is less than or equal to 3. So it's similar to number 1 that has the equal to component. You can see the line underneath right there. So we go back to 3, 1, 2, 3, and now instead of an open circle, we're going to have a closed circle. This indicates that x can equal 3, and then since it's less than, again, we're going to draw an arrow to the left. All right, number 3. Let's start with our number line. So number 3 has actually kind of 2 inequalities with the word or. It says x is greater than 4 or x is less than 0. So x is greater than 4. We go over to positive 4 on the number line. 1, 2, 3, 4. Open circle because it cannot equal 4. Greater than will go to the right. Then we have x is less than 0. It cannot equal 0. So another open circle. Less than will be all the numbers to the left. So in this inequality, x can be greater than 4 or less than 0. It obviously can't be both of those at the same time. And number 4, our last example here. All right, so in this case, we have to read this inequality correctly. We always start with the variable that's in the middle, and we read it from the middle to the outside. So the first piece that I'm going to read is this piece, and we say x is greater than or equal to negative 3, and x is less than 1. So let me read that again. X is greater than or equal to negative 3 and less than 1. Okay, so let's look at how to graph this. X is greater than or equal to negative 3. So we go over to negative 3. It has the equal to component, so we're going to have a closed circle. Greater than negative 3 would be everything to the right. And x is less than 1. So if we're graphing x is less than 1, we're going to have an open circle, and we're going to graph everything that goes to the left. Now, notice that we've covered the entire number line. But when reading the inequality, it says x is greater than or equal to negative 3 and less than 1. And means it has to obey both of these inequalities at the same time. So looking at what you see on the number line, we are looking for the part of the number line that has been overlapped. It's overlapping in both of them. And that is this piece right here. So let's go back a little bit. And we know, according to our inequality now, that when we graph this, x has to also be less than 1. So we're going to go to right there, and we're going to have an open circle on 1. So there is the final graphing of that inequality. All right, next we're going to define absolute value. Absolute value is the distance from 0 to a number on the number line. Because absolute value describes a distance, it is never negative. All right, so you probably remember absolute value as simply taking the number inside of the absolute value symbol and making it positive. So the absolute value of negative 3 would be positive 3. The absolute value of 5 would be positive 5. And the absolute value of 0 would be 0. But let me make sure you understand the definition of absolute value here. So if we have a number line, and we look at our three values, negative 3 is right here on the number line. Now, how far is negative 3 from 0? Well, it's 1, 2, 3. 3 units away, and so that's why the absolute value of negative 3 is positive 3. All right, let's look at positive 5. Here's positive 5. 1, 2, 3, 4, 5 units away. That's why the absolute value of positive 5 is 5. And finally, we have the absolute value of 0. Well, of course, 0 is right here. And how far is 0 away from 0? Well, 0 units. So remember the definition that absolute value is the distance from 0 to a number on the number line. All right, next, addition and subtraction of integers. We should all be pretty good at this, but if you need a little review on some basic skills, this is it. So we're going to find each sum or difference, and I'm going to talk about some of the rules as we go through these. All right, negative 7 plus 3. Well, first let me show you how addition and subtraction can be done on a number line. All right, so this problem is -7. So let's find -7, 3, 4, 5, 6, 7. So here's -7 plus 3. Plus 3 on the number line would move us to the right 3 places, because positive means move right. Now, what is that value? -1, -2, -3, -4, right there. So the answer to this is -4. So on a number line, addition moves you to the right, subtraction moves you to the left. In fact, addition and subtraction can always be done on a number line. Now, we usually don't do that because we remember certain rules. For example, in number 1, you probably remember that since 7 is bigger than 3 and it's negative, our answer is negative, and we're subtracting. So -7 plus 3 is -4. All right, let's move on. -7 plus a -3. Well, you probably remember that when we add two negatives together, we add the numbers and we keep the answer negative. So -10 is our answer. Number 3, 8 minus 15. Well, now the 15 is bigger, and since that's what we're subtracting, our answer is going to be negative. And 15, the difference between 15 and 8 is 7. So -7 is our answer. And finally, number 4, -6 minus -19. Well, you probably remember that when you subtract the negative, it's like adding a positive. So this problem is the same as -6 plus +19. All right, which can also be thought of as 19 minus 6, which is 13. All right, so addition and subtraction can be done on a number line, but if you remember the rules, you certainly don't need to do that. Multiplication and division of integers. All right, so once again, we're reviewing some very basic skills, but they are essential. All right, 6 times -9. So remember, a positive times a negative is a negative. -54, because 6 times 9 is 54. Number 2, a negative times a negative is a positive, so our answer here is +40. Number 3, anything times 0 is 0. Number 4, a negative divided by a positive is a negative, and 12 divided by 4 is 3. Number 5, 60 divided by -6, so a positive divided by a negative is a negative. Number 6, 0 divided by anything is 0. Number 7, -7 divided by 0. Well, you better remember that you can never divide by 0. And so number 7 is undefined. There is no solution. And finally, number 8, a positive times a positive is a positive. And we have our answer of 80. Okay, you should be able to do these types of problems in your head without the aid of a calculator. Next, we'll talk a little bit about exponential notation. As you can see, each one of these problems has an exponent, but there are some rules of exponents that we have to make sure that we remember. Number 1, 3 squared. Anytime something is squared, it's like it's being multiplied by itself that number of times. So 3 times 3 is 9. 3 squared is 9. Okay. Number 2, -3 squared. So in this case, since the -3 is in parentheses, it's -3 times -3, because we're squaring what's in parentheses. -3 times -3 is +9. Number 3, -3 squared. Now this looks similar to number 2, but there are no parentheses. This is one that you have to be careful on. -3 squared, as you see it here, is the same as writing negative and then 3 squared. And we only want to square what's inside the parentheses. 3 squared is 9. We're going to keep the negative. This answer is actually -9. Now, the difference between numbers 2 and 3 is very important. These cause a lot of confusion for students, and I'll remind you of this over and over again throughout the year. All right, number 4, 4 cubed. When it's cubed, it's like it's multiplied by itself 3 times. So 4 times 4 is 16. 16 times another 4 is, let's see, 16 and 4. 4 carry the 2, 64. 64 is our answer. Number 5, negative 4 cubed. Since the negative 4 is in parentheses, it's negative 4 times negative 4 times negative 4. So a negative times a negative is a positive, so this is positive 16 times negative 4, and then we end up with negative 64 here. And finally, number 6, once again, there's no parentheses, so this is the same as cubing just the 4. So we're going to bring down our negative sign, and we know from number 4 over here that 4 cubed was 64, so this is also negative 64. Next, we talk about the order of operations. You may remember the saying, "Please excuse my dear Aunt Sally." And this tells us that when doing a math problem, we do what's in parentheses first, followed by any exponents, then multiplication, division, addition, and subtraction. Order of operations is so important in math. Your calculator, for the most part, knows order of operations, but sometimes if you don't put things into the calculator correctly, then you are misleading yourself in terms of what the answer should be. All right, so let's take a look at some examples. Number 1, it says evaluate. That means find out what this equals. So we have negative 5 minus 6 times negative 3. Using order of operations, we would do anything that's in parentheses first. Well, as you can see, there's parentheses, but there are no math operations inside of those parentheses. So there's nothing to do there. There are no exponents, so we move to multiplication. And here, you can see we have negative 6 times negative 3. That's a positive 18. We can drop the parentheses around negative 5, and all of a sudden we have negative 5 plus 18. That is 13. Number 2, there's lots going on here. We have division, we have multiplication, we have some parentheses, but there's no math operation going on there, so there's nothing to do inside parentheses. All right, so let's put this to work. Now, let's go back real quick. You can see that in this list, multiplication comes before division, and addition comes before subtraction, but it's important to know that multiplication and division, whichever comes first from left to right, you do first. The same for addition and subtraction. Whichever operation comes first, you do it first. So what I'm talking about here is the division is coming before the multiplication, so we need to do the division first. All right, so 10 is going to stay there. We're going to bring this minus sign down. 100 divided by 5 is 20. Times 2 minus a negative 3. We might as well go ahead and change that. Well, no, we'll leave it there for now. Okay, now we have multiplication. So 10 will bring down the minus sign. 20 times 2 is 40 minus a negative 3. Now, we can work from left to right. 10 minus 40 is negative 30, minus a negative 3. Well, subtracting a negative is the same as adding a positive, plus positive 3. So negative 27 is our answer. Finally, in number 3. So now we have some parentheses with math operations inside, and we have some exponents. All right, so first we do the parentheses. We have negative 6 squared minus 5 minus 7 is negative 2. All right, this parentheses happening right here means multiplication. So we're going to have a negative 2. Let's keep that in parentheses. And we're going to square, well, let me just rewrite this for right now. We'll do it step by step. Okay, so now we've done what's in parentheses. Next, we need to apply the exponents. All right, so we have negative 6 squared. That's negative 6 times negative 6. That's going to be positive 36. All right, minus negative 2. And then we have negative 3 squared. That's negative 3 times negative 3. That's going to be positive 9. All right. Next, we have multiplication. Negative 2 times 9 is negative 18. And finally, subtracting a negative is like adding a positive. So this is 36 plus positive 18. That's going to be 54. All right, so you've seen the order of operations in action. It takes a lot of practice, a lot of repetition to make sure that you can apply order of operations correctly. All right, this lesson has covered a lot of material. If you need to go back and watch it again, you certainly may do so. This has been section 5.2, the integers and order of operations.